Hello everyone, this is your tutor AB, and today we're going to be looking at an example problem from the Gravitation's D.1 topic in the new 2025 IB Physics syllabus. This is an SL question and this is 1 mark. Okay, so Kepler's third law relates to the orbital period t of a planet that is about its sun to its orbital radius r. The mass of the sun is m. What is the correct algebraic form of the law? Well, I'm not going to derive the equation now, but Kepler's law is t square is equal to 4 pi square r cubed over gm. Essentially, you derive Kepler's law by equating centripetal force to gravitational force. When you equate these two together, you can derive the Kepler's law, but I won't be deriving it this video. So they're asking, how can I algebraically form the law? Well, this is the law, isn't it? Well, no, because we have t alone on one side, whereas in the law we have t square. So we need to shift the square root across this RHS of the equation. So t is equal to the square root of 4 pi square r cubed over gm. Now, the rule of mathematics is that every root can be represented as a fraction, and this root can be distributed throughout every single term in this fraction. So let's rewrite this, shall we? So t is equal to, well, it's going to be 4 to the power of 1 by 2, which is nothing but the root of 4 times pi square to the power of 1 by 2, which is again nothing but the root of pi square times r cubed to the power 1 by 2, which is nothing but r cubed root of r cubed, and at the bottom we have gm to the power of 1 by 2, which is nothing but the square root of gm. So if we distribute this value throughout each term, we get the square root of 4 is equal to 2, and we know that exponents multiply with each other in this case because you have one on top of the other. So 2 multiplied into 1 over 2 just gives us pi alone, so that's 2 pi. Then again we have 3 multiplied into 1 over 2, which then becomes r to the power of 3 over 2. Then we have at the bottom gm to the power of 1 over 2, which we can say is just 0.5. So this is how we algebraically represent this question. So let's take a look at our options. We have 2 pi r is 3 over 2, which is also equal to 1.5. So we can look at our answers. It's not this, it's not this. Our final answer is